All right, guys, here is your video key for the non-calculator portion of the 2012 multiple choice questions. Number one, we're just finding the derivative here. So this is product rule. Here's my u, here's my v. So we do the derivative of the first, which is 1, times the second, plus the derivative of the second, which is cosine x, times the first, which I'm going to write that x out in front. And we get sine x plus cosine x, which should be answer B. I'll just swipe over and check all these answers as we're going. Number 1B is correct. Hopefully you guys do that as you're doing the problems on your own. Number 2, also don't forget I'm going to talk fast on purpose to get the video, make the video as short as possible. You guys, of course, can pause, rewind, do whatever you need to do. So now we're looking for intervals of increasing given a function f, which means we have to find f prime of x. That's going to be 300 minus 3x squared. We want to know when that equals 0, and then we'll make a sign chart. So find our critical points, and you get x equals plus or minus 10 when you solve that. And so then we can make a sign chart here. We got f prime of x, f of x, negative 10, and 10. Now I quickly solved this equation up here, but to have the derivative in factored form is nice when making a sign chart. So I'm going to take out a negative 3 from this, which then it factors into x minus 10 times x plus 10. Because then we can just plug in like negative 20, and we have a negative here, and a negative here, which will result in a negative, so we're decreasing. Then plug in something like 0, and when you do that, you have a negative here, and a positive. So that's a positive answer, which means the function then increases. And then a number bigger than 10, you get negative, positive, which will again be negative. We're looking for intervals in which the function is increasing, which will be between negative 10 and 10, which is 2b. That is correct. Notice here how the answer actually uses brackets. That could be parenthesized, and it would be fine also. They would never give you both options, but sometimes they use parentheses, sometimes they use brackets. This is the Count Dracula quiz, or Count Turkula quiz question, because you should know that this is the derivative of secant x, and therefore the antiderivative is secant x. 3 is A. Number 4, we got to find f prime of 1 given f. F prime is going to be 7 plus 1 over x. And then you plug in 1, evaluate at x equals 1, and you get 7 plus 1, which should be 8. 4 is then E. That is correct. All right, number 5. I have some of highlighted in here, and this is just questions I wanted to make sure we discussed as a class when we're in class together. So you can kind of ignore that, but that's why you'll see some highlighted problems. All right, on this one, which of the following statements is false? The limit as x goes to 2 exists. Remember, for a limit to exist, it's got to go to the same place from both sides. This does. It does not matter that there's a hole there for a limit to exist. So the limit does exist here, which means that is true, therefore it's not false. Limit as x goes to 3, again, goes to the same place from both sides. They both go to the same y value, regardless of whether or not that y value exists. So this cannot be the answer either, because that is true. Limit as x goes to 4. We go here. The limit is that y value from that side, but it's that y value from that side. Those limits are not the same. Therefore, this is the one that's false. Let's just look at the other statements. As x goes to 5, both sides go to the same y value. And the function f is continuous at x equals 3 is also true. Okay, it's continuous because the limit from both sides goes to the same value, and that value is the same as the limit. So what they're trying to trip you up on there is the fact that there's a corner or a cusp there. That means it's not differentiable. Okay, so our answer is C. Number 6, we got a particle moves along the x-axis. We're given the velocity. What is the total distance traveled? So on this one, total distance traveled, remember, you got to look at the graph of this. Now we're looking only from 0 to 3. You should know that this graph is t times 6 minus t. And so it has a 0 at t equals 0. And t equals 3, or sorry, 6, and therefore it does not change signs between 0 and 3, which means the particle does not change direction. So we don't have to split this into two different integrals. Remember, we're looking for area above minus area below when doing total distance. Since this area that we're looking at is all above, all we have to do is the integral from 0 to 3 of 6t minus t squared dt, which is 3t squared minus t cubed over 3. And then you evaluate that from 0 to 3. Plugging in 3 gets us 27 minus 9, I believe. And you plug in 0 and you get 0. And so the answer should be D for number 6, which it is. Number 7, we're just finding the derivative here using power chain rule. Bring the 5 down, keep the inside the same. To the 4th power, multiply by the derivative of the inside, which is going to be 3x squared. And then the derivative of cosine is negative sign, so that becomes a plus sine x. So that looks like it is answer E. For 7, the answer is E. That is correct. Number 8, we're given the rate at which oil is being pumped into a tank, and we know that there's 50 liters to begin with. Use a right Riemann sum with 3 subintervals and data from the table. What is the approximation of the number of liters? So this is where you do an integral, but we're going to use a right Riemann sum to estimate the integral. And we're going to use a right one. So between 4 and 7, we're going to use this as our height. So the first rectangle is 3 times 6.2 plus, now we're looking between these two. So from 7 to 12 is a base length of 5, and we're going to use a height of 5.9. If you have trouble visualizing this, you can just plot these data points and actually draw the rectangles. It's not the most efficient way, but if you need to, it's certainly helpful. And then we have a base length of 3 from 12 to 15 and a height of 5.6. And then don't forget to add in the initial 50. Okay? Remember, the area gives us the amount of change, and then we got to add that to the initial amount. Okay, so that should be, let's see, 18.6 there, plus... This is basically 6 times 5, which is 30, and then minus 0.5 is 29.5. That's how you can do that without a calculator very quickly. 3 times 5.6 is 16.8 plus 50. Hopefully those numbers all add up to, I believe the answer here is C. Let me double check that. Number 8 is in fact C. We're going to have 0.3, 0.9. So this should work. Looks like we have... adding these together, that's 0.11, 0.19, so 1.9, so we have a 0.9, and another 1, so then we have 19 plus 29 is 48, plus 6 is 64, plus 50 is 114. Okay, so all those numbers are right. Number 9. All right, so for what value of k is this function continuous? Clearly, the given function is not continuous at x equals 2 because you can't divide by 0. But this problem, they made it as easy as possible for us because it's already in factored form. This is kind of like a limit question, essentially. Remember, if you cancel out the x minus 2's, anytime you cancel out a factor that would otherwise cause a vertical asymptote, normally we think there's a vertical asymptote at x equals 2 on something like this, but when that factor cancels, it creates a hole. So the graph looks exactly like this line, y equals 2x plus 1, which looks something like this. I totally missed. There we go. That's a lot better. So this is the line y equals 2x plus 1, except at x equals 2, it can't exist because it couldn't exist before we simplified it. So at x equals 2, if I plug in 2 right here, I would get 5. So we have a hole at 2, 5. 1, 2, 3, 4, 5. Let's hope those line up close enough. So if we let this equal 5 when x does equal 2, it's now a continuous function because all we did was have one point missing, so we just filled in that point. Okay, that's what's going on there. Get off there. Cut that. All right, number 10, what is the area of the region in the first quadrant bounded by the graph of y equals e to the x over 2 and the line x equals 2? So you should know that E roughly looks something like this. Okay, and then we're bounded by the line x equals 2, so we have that. So we're just doing the integral from 0 to 2 of e to the x over 2 dx. Now you can use substitution here if you want, Or you can say to yourself, all right, if I did the derivative of e to the x over 2, I'd have to multiply by 1/2 because of chain rule. So therefore, if I'm going the other way, I got to multiply by 2 or divide by 1/2. So it's 2e to the x over 2 for our antiderivative evaluated from 0 to 2. Gets us 2e to the first, which is just 2e minus 2e to the 0, which is just 2. So 2e minus 2 looks like. Number 10 is A. That is correct. Moving on to number 11. Which of the following statements is true? F is continuous but not differentiable at x equals 2. Maybe you know what the absolute value does here, but basically with the square root function, x minus 2 is going to shift it to the right 2. So it's going to start here, and it's going to look like that for the square root. But since it's absolute value, now negative numbers are allowed to work too. So this graph's going to look like that. And hopefully you notice there that's actually going to cause a cusp. So which of the following statements is true? Continuous but not differentiable at x equals 2 should be the right answer here. 11 is in fact A. F is differentiable. So the answer has to be either A or B based on those two statements. Like one is saying it's not differentiable, the other is saying it is. F is not continuous at x equals 2. Well, it is continuous at x equals 2 because you can just plug in 2. If you plug in 2, I mean, technically you got to show that the limit from both sides is the same, but you know there's not going to be a jump in this graph because we have knowledge of graphs. This says the limit, so these two are actually kind of connected because this says the limit as x goes to 2 is 0, and we just found f of 2 up here to be equal to 0. And so that's the definition of being continuous at a point. And hopefully you know that e is not right because x equals 2 is not a vertical asymptote. That has nothing to do with anything with this function. Number 11, using u substitution, what is the following equal to? So this is the problem I actually alluded to a long time ago where they force you to change the bounds because all the answers are just written as different integrals with changed bounds. Well, some of them don't have changed bounds, but those are wrong. So if our u is square root of x, then our du is 1/2 x to the negative 1/2 dx. And that's the same thing as saying 1/2 times 1 over square root of x dx. And I wrote it like that because this portion is in our integral right here. That's the same thing as 1 over square root of x dx. So we need to throw a 1/2 in there. So that's where we do this thing right here. We throw a 1/2 in front, and therefore we need a 2 out there to cancel it out. Okay? So this becomes 2 times the integral. The 1/2 I put in there, and all this other stuff just becomes du. And then instead of e to the square root of x, it's e to the u because u is equal to square root of x. So it's 2 times e to the u du. Now, the original bounds are x values. We can use this equation right here and figure out what u is when x is certain numbers. So we plug in our lower bound when x is 1, u equals 1. So our lower bound is 1. When when x is 4, u is equal to 2. So our upper bound is 2. So that is the rewritten version of this integral. 12 is C, that is correct. Number 13. All right, so we got to find an integral, but the function is defined by two different things depending on our bounds. So on this one, you have to do the integral from 1 to 3 of 2 dx plus the integral from 3 to 5 of x minus 1 dx. It's just two different functions. So graphically, this looks something like this. We have a horizontal line and then something like that. So we're just finding areas separately like that. And you actually could graph this and find the areas because they're known shapes. If you integrate a line, that's a triangle or a trapezoid. And if you integrate a horizontal line, that's always a rectangle, if you recall from stuff we did earlier this year. Now this is an integral of a constant, which is going to be this constant times the interval length. So that answer is 4. Or you can do the antiderivative, plug in the upper bound, lower bound, subtract. I'll do antiderivative here and get x squared over 2 minus x, evaluated from 3 to 5, is 25 halves minus 5 minus 9 halves minus 3. And so that should give us, let's see, that's going to be 16 halves, so 8, and then minus 2, which is 6. And that gets combined with our 4 that we got from the first integral, so we should have an answer of 10, which is D. I forget what number we're doing. It looks like 13 probably. All right, and that is correct. All right, number 14. So derivative of a composition. So this one, you could either do the abstract derivative of f of g of x, which is f prime of g of x, derivative of the outside, keep the inside the same, times the derivative of the inside, and then just plug in numbers for that. Or you, since here they actually give you the two functions, you could find the composition and then just find its derivative and plug in 3. I'm going to do it this way. So now we need f prime of g of 3 times g prime of 3. Okay, so we need f prime. F prime of x is equal to 1/2 x squared minus 4 to the negative 1/2 times 2x. And g prime, we need that too. Well, that's easy. It's just a line. So g prime is 3, no matter what we plug in. So g of 3, we also need. G of 3, just plug 3 into this, and you get 7. So now we have f prime of 7 times 3. And then f prime of 7, take 7, plug it into f prime. Our 1/2 and 2 can cancel there. And you get 7 over square root of 45, it looks like. So we have 7 over square root of 45 times 3, which is equal to 21 over 3 radical 5. So 7 over radical 5. Answer is A for number 14, which is correct. Again, I am just double checking because I do make mistakes every once in a while, especially when I'm going through them very quickly like this. All right, this problem, we have a graph of f. H is equal to the integral of f. Okay, so that means h prime is equal to f, and h double prime is equal to f prime. Okay, so now we're looking at values at 6. So h of 6, which is the integral from 0 to 6, which is this, is negative. So h of 6, we know, is negative. Basically, on a question like this, one answer is going to be negative, one answer is going to be positive, one answer is going to be 0, and then you just compare the 3 values. So h of 6 is 0. H prime, which is equal to this graph, this is the graph of h prime. H prime of 6 is the y value right here, which is 0. H prime of 6 equals 0. And then h double prime of 6 is the slope at 6. And the slope of this line right here is positive. Okay, so h double prime is the biggest. H prime is equal to 0, so that's in the middle. And then h is the smallest, so 15 should be A, which it is. All right, 16, we got a particle moving along the x-axis. For which of the following values of t is the particle at rest? So that means we want to know when the velocity is 0. So we find x prime, which is equal to velocity. So I'm going to do product rule. You could like FOIL this if you really wanted to. But product rule, so the derivative of the first thing is 1 times the second is just the t minus b, plus the derivative of the second, which is also 1, times t minus a. And we want to know for what t value this equals 0, because that's when the particle is at rest. So you get 2t equals b plus a, or a plus b, divided by 2, and you get t equals b plus a over 2, which is 16 is b. I already know that one's right, but whatever. We'll check it anyways. And it is. All right, 17. The figure above shows the graph of f. If f is the integral, which of the following could be the graph of g? So if f is the integral, that means f prime equals g. So what is this? What is the derivative of f? Some constant positive function. So this is the only thing that makes sense there. So 17 is A. Okay, just checking. I know it's right anyways. All right, this question is actually, if you remember a long time ago, chapter 2, this is the limit as h goes to 0 of f of a plus h minus f of a all over h. This is the limit definition of derivative. How exciting. Our function f right here is natural log right there. So we're finding the derivative of natural log at what value? This value, a, which is 4. So all this is asking us is to find the derivative of natural log of x, which is 1 over x, at x equals 4, which is 1 over 4. like the easiest question we can do mathematically, so the answer should be B. It is. But it's one of the easiest questions to actually do, but it's difficult for students to understand that that's what you're supposed to do. So hopefully you recognize that as being the limit definition of a derivative, and you can distinguish that or determine that you're trying to find the derivative of natural log at x equals 4. Number 19, what points on the graph of f have the property that the line tangent has a slope of 1/2? So we're finding the slope of this and finding when it equals 1/2. The slope, of course, is f prime. Doing quotient rule, the derivative of the top is 1 times the bottom, x plus 2, minus the derivative of the bottom, which is 1 times the top, which is just x, all over x plus 2 squared. And then that simplifies to 2 over x plus 2 squared. And now we got to do some algebra and show where this is equal to 1/2, because that's what it's asking, to find when the slope is equal to 1/2. We can cross multiply and get 4 equals x plus 2 squared. And then square root both sides, and you get plus or minus 2 equals x plus 2. Subtract 2, and you get x equals negative 2 plus 2 is 0, or negative 2 minus 2 is negative 4. You can check and just plug these points in and into the original function for your x values and get your y values and make sure you actually get the answer C. You do. So what number are we on? 19. 19 is C. Okay, but you could check that, because if you didn't get those y values, then you know your x values are wrong, and you made a mistake somewhere. You can go back and try to figure it out. All right, derivative of an inverse on number 20. For this particular problem, they give us the function f, so you could actually find its inverse, but I'm going to remind you what the derivative rule for an inverse function is. The derivative of f inverse of x is 1 over f prime of f inverse of x. Now, in this particular problem, they're calling the f inverse g. So this is 1 over f prime of g of x. Since we know f of 0 equals 1, we know g of 1 equals 0. And we're trying to find g prime of 1. So this is equal to g prime, because g prime is the inverse. So that means we are doing 1 over f prime of g of 1. G of 1, I just explained, is equal to 0. So you get 1 over f prime of 0. And f prime of 0, we got to find f prime and plug in 0, and you get 3 times 2x plus 1 squared times the derivative of the inside, which is 2. Plug in 0, and you get 1, 3, should you get 6, it looks like. So you get 1 over 6, which is D. 20 is D, is correct. Okay. I don't know if you guys can hear, but my kids are just screaming nonstop. 21. The line y equals 5 is a horizontal asymptote to the graph of which of the following functions? Remember, horizontal asymptotes are end behavior. End behavior occurs as x gets really, really big. This is all Bill Gates philosophy. Okay? If you plug in a really big number, this stays between -1 and 1. This gets super big. This actually goes to 0. Y equals 5x. Hopefully you know that doesn't have a horizontal asymptote. It's a line. I don't even know why that one's on there. This has a vertical asymptote at x equals 5, so it's not that one. As x gets really, really big, this number does not matter, and you get 5x over negative x, which is -5, so it's not that one. And as x gets really big, this number is too small, this number is too small. X squareds cancel, and you get 20 over 4, which is in fact 5. So the answer is E. Love the Bill Gates philosophy. 22, let f be the function defined by that. What is the absolute maximum? So to find an absolute maximum, we got to find the derivative. Let's make a sign chart. F prime of x, we'll find the critical points. Derivative of the top is 1 over x times the bottom minus the derivative of the bottom, which is 1 times the top, all over the bottom squared. Okay, so this is actually simplifies into 1 minus natural log of x over x squared. This is undefined at x equals 0, so that's a critical point. But x equals 0 is not in the domain of the original function either, so it's not going to be a critical point. I mean, by definition, it's a critical point, but there's not a maximum in there. So we're only concerned with the numerator then. 1 minus natural log of x equals 0, which means natural log of x equals 1, which means x equals e. You should know that natural log of e is equal to 1. So that is our only critical point, which seems like a weird number to have to plug in. But we're going to look at f prime of x versus f of x. F prime. So what we can plug in is like e to a negative power, because that will be less than e, because that's going to make it 1 over e. So if we plug in like e to the negative first, right here, so we plug in e to the negative first, you should know that that's going to give us -1, because it's natural log of e to the negative first. So like there's actually an e right here when these bases match. The answer is just that. Hopefully you remember that property. And then I'm making a video. And then, so we get -1, so you get 1 minus -1, which is positive. So we're positive on this side, which means the function's increasing. And then we could pick like e squared or something, and that answer is going to be 2. So then you get 1 minus 2, and you get a negative, which means it's decreasing. So we have a max at e. Notice how it says, what is the absolute maximum value? So now we got to plug e into this because we know where the maximum is, but we got to find what it is. Natural log of e over e, which is 1 over e. So the answer should be 1 over e for 22, which is B, and that is correct. 23, which of the following differential equations describes linear growth in the size of the population? So which one of these goes up by a constant amount is all that's asking, because lines go up by a constant amount. So that means your rate of change needs to be a constant, and that's this one. It's the only one that has that goes up by the same amount every time. Your rate is 200, which means the slope of your line is 200. So 23 is A. Okay, 24. For what value of K does G have a critical point at 2/3? So critical points are when the derivative is 0. So we're going to find the derivative. We know it's at x equals 2/3. We plug in 2/3 and just solve for K. So our derivative, G prime of x, using product rule, is 2x e to the kx plus ke to the kx times x squared. And then we plug in 2/3 for x. So you get 2/3, 2 times 2/3 e to the 2/3 k plus 2/3 e to the 2/3 k times 2/3 squared, which is 4/9. And we want to know when this is equal to 0. Okay, so you can take out the e to the 2/3 k. And that part can never be 0, so that's nice. So what I'm doing is I'm getting rid of these two things. So we have, let's highlight it in yellow. We have these numbers left over. I'm missing a k somewhere. Oops, I accidentally plugged in this 2/3 for k. That should be a k, not... There should be a k there. All right, so now we have 4/3 plus 4/9 k with all the highlighted yellow stuff when I take out the e to the 2/3. This can never equal 0, so now we just do 4/3 equals -4/9 k multiplied by -9/4, and hopefully we get k equals -3. 24 is A. That is correct. (25) Which of the following is the solution to the differential equation with that initial condition? So we find the antiderivative, y equals -2 cosine x plus c. We plug in pi for x, cosine, and 1 for y, so you get 1 equals cosine of pi is -1, so you get +2, plus c, which gives us a c value of -1. And so it's just -2 cosine x minus 1, which looks like it's E for 25. 25 is, in fact, E. Okay, get rid of that. 26, a couple more here. Which of the following must be true if g prime is equal to that integral? So what we should know about any exponential is that it is always positive. So this graph is always above the x-axis, which means g prime is always positive. G prime of x is always positive. G double prime is equal to the integral, or the function that we're integrating, e to the -x squared, which is also always positive because it's an exponential. So if g prime is always positive, the graph is increasing for g, and if g double prime is always positive, the graph is concave up. So 26 should be, A, and it is. We haven't messed one up yet. This is perfect. And 27, what is the value of the second derivative at 3, 0? So we got to find the second derivative here. This one's weird how they write it. Just divide by this to get it on the other side, and then we'll use quotient rule to find the derivative. You get 2x minus y over x plus 2y. Okay, so the derivative of that, so the second derivative of the top is 2 minus y prime times the bottom, x plus 2y, minus derivative of the bottom, which is 1 plus 2y prime, times the top, 2x minus y, all over the bottom squared, x plus 2y squared. And then it's at the point 3, 0. So these y primes right here, I think the easiest way is use this and plug 3, 0 into that and then just substitute that number. So it's at 3, 0, so evaluate it at 3, 0. We get 6 minus 0 over 3 plus 0, which should get us 2. So those y primes are equal to 2. What's nice about that is if y prime is 2, then this whole thing is 0. So that's all gone because you would get a 0 inside this first parenthesis right here where that y prime is. Okay, so that's gone. And then, so we're evaluating this at 3, 0. So now we have, we're just looking at, let's highlight it in purple here. So now we're just looking at this purple stuff. This is all we need. And so we have negative 1 plus 2y prime. Y prime was 2, so it's 1 plus 4 times 6 over 3 squared, which is 9. And it looks like we should get negative 30/9, which is negative 10/3, which is answer A for 27. That is also correct. And 28. We have a position. What is the acceleration when the velocity first equals 0? So find the velocity. There's some shouting. All right. So I'm making a video. And so we find the derivative of sine, which is cosine t. Do the derivative of negative cosine. So the derivative of cosine is negative sine, so plus sine t. Sorry for that interruption. I think my puppy is driving people crazy, I guess. So she was just put in her cage right next to me. She'll probably start barking, is my guess. All right, where was I? I found this derivative. We got to find when this first equals 0. Okay, this equals 0 when cosine t equals negative sine t. So when cosine and sine have opposite values. From a unit circle, you should know that that's going to occur at t equals 3 pi over 4. Okay, and then if it's at 3 pi over 4, then we're just finding the acceleration at that point. So we're going to find the derivative of this to give us our acceleration. So a of t then is negative sine t plus cosine t. Sine of 3 pi over 4 you should know is radical 2 over 2. And cosine you should know is negative radical 2 over 2. So it's plus negative radical 2 over 2, which is negative 2 radical 2 over 2, which is negative radical 2, which the answer for 28 is A, which I already looked and verified when I looked at the last question. So that is it. I hope you find this useful as always. Goodbye.